Alright folks, so in this section we're going to learn how to sketch the graphs, kind of like what I've been doing at the end of every problem so far. But we're going to add an extra layer here, which is the asymptotes, and we're going to be discussing rational functions. So what is a rational function first of all? A rational function is basically a function or a problem that has a fraction. So you'll see down here, this is an example of a rational function. So these usually have pretty interesting graphs. The graphs are not always connected. There's usually gaps and things like that. So that brings us to the first topic, which is what is a vertical asymptote. So in order to explain what a vertical asymptote is, let's go to a separate piece of paper here, and let me just kind of bring a graph of the xy plane, and let's define what a vertical asymptote is. So usually we say there's a vertical asymptote at x equal to some random number. So let's say the x is 3, for example. If I say x equal 3 has a vertical asymptote, what am I really talking about? Here's what I'm talking about. I'm talking about this. If I go to the place where x is 3, then there's going to be some sort of an invisible line where the graph cannot cross this invisible line. So my function is going to tend to get closer and closer to this line, but never be able to cross it. So it may do something like this, or on the other side, it may be able to do something like that. It's going to get close to it, but not ever cross it. Or maybe possibly go down before, and maybe possibly, I don't know, who knows what, maybe go down after. So we say that this 3 is a vertical asymptote if the function is doing any of these behaviors. Now, kind of professionally speaking, to say that the function is going up, we don't use the words up. We normally say the limit as x approaches 3 from the left on this function f of x is plus infinity. So this behavior kind of describes what's going on right there on that section. On the other hand, to say that the function is going up after 3, we would say something like the limit as x approaches 3 from the right on this function f of x is positive infinity again. So that literally describes what's going on kind of over here. That's what we're saying. Okay, but for a vertical asymptote to exist, you don't have to have these two. You could have the function going down. So how do you say that it's going down? You say something like this. The limit as x approaches 3 from the left on this function f of x is negative infinity. So this would mean that my function is going downhill before I arrive to 3. And finally, we could say the last one in such a way, limit as x approaches 3 from the right on this function f of x, we could say it's negative infinity. So this would imply that the function is kind of going down as I come towards 3. So all these things, if you have one of these limits, you don't need to have all 4 of them. If you have one, let's say, out of these 4, or maybe this one, whatever, it doesn't matter which one, we say that 3 is a VA. Okay, so does that make sense? Let me know if it doesn't make sense, and I'll try to put another video with another answer.